Okay, am I live now? Can someone see my screen? I think I'm live. Wait. I think I'm okay. So just to quickly do a few chess matches and then just continue. I don't know who is online. Whoever is online, thank you. I think it's me only. Okay, I can see it. Seems to be live. Beautiful, okay. Just a quick yes. I mean, of course, I am. Okay. I think it's a good idea. Okay, maybe. I don't know. What else we can do? Why do I feel like it's going in a design direction? Maybe. Okay. Check. Then. Also, can you guys hear me? I don't know. Okay, audio seems amazing. Okay. Okay. What is this? I think I know where it's going. I think I lose. Yep. I expected that much. Okay. Okay, that's great. I'm basically cooked. Okay. Then. Oh, that was a mess up, I think, because I'm directly in root control. Beautiful, perfect. Can I do this? As you can see, I'm trash at chess again. We'll talk about what we are going to do today. Just quick brain drain. I think I should just resign, maybe. Oh my god, this is so good. Bye. Okay, so. Oh, what is this sound? I'll just quickly discuss what we are going to do today. I'm slightly drunk, sleepy, I don't know. Very tiring. It's been a long time. Okay. So, as you guys remember, the last stream was about Tankyū-sha. So, if you don't know, it's basically an aid assisted digest platform. So, but wait, let me change the music. It's actually pure shit. What should I put? Maybe I remember some lo-fi chill beats. Okay. Oh, it's much better. Okay, cool, beautiful. So, uh, last time we had a stream that was about Tankyū-sha. So Tankyū-sha is basically AI assisted digest platform. So what it does is just give it a few topics and it goes around, looks in the internet, and just finds out relevant information. And what it will try to do is it will just pass it to some LLM or something, and then maybe get a digest or a summary, and it will also vectorize and store them, so that let's say if you have some cross question that you want to do on the content itself, and then you can just ask it around, get some answers, and yeah, just works like that, right? And it's pretty simple. I mean, that's the outcome mostly. And how it works is a few things. So I mean, maybe I would like it to be in like interface it via some MCP or something. But for now, I don't know. Maybe some, I don't know. Like, we'll think about it. For now, it just CLA app as of now. I'll think about how we can interface it later, right? Oh, and I don't know. Maybe so the way I want to distribute it is also very simple. Basically, it's going to be a Docker image, and because it uses Playwright to load, like, get information from the internet. So of course, I mean, that's going to be there. So I haven't containerized it yet. I'm thinking about it, but more or less it's going to be that. And all that JavaScript code that you see is basically for scraping, because Gleam apparently doesn't have any full CTP implementation yet, I think. Oh wow, yeah, this was 6 months ago. So I tried to fork it and make changes, but that's, I mean, I found out it's just very difficult to understand CTP protocol and just go about it, right? So I just left it there. Then I think it's more or less there. So what I did is I just like decided to put, like, like all uh scrape like reading website and all that logic into Playwright, and then spawn a node of Elixir processes, and then interface it. But maybe going forward we can put it in Docker, and then, like, split containers and then talk to each other and all that stuff. I started it, but then I'm like, okay, it's too much work, and maybe I should just focus on the POC. I'll just quickly give you an overview of how it works right now. uh, I think this is the last stream. So what I'll do is I'll just move it left and restart it. So basically the progress in the last 3 months is three. It's slightly drunk, so it's difficult for me to focus. But yeah, just tell me if it gets difficult to understand or follow, right? So last 3 months, I think maybe I just went around and figured out a few things. So mostly around how do we load internet from the internet, right? I mean, data from the internet, which is news, blog, just basic like uh, feed as in like LinkedIn feed, Twitter feed, whatever, and just putting a structure around that. That's what I've spent most of my time last few months. I think, again, I didn't get too much time to work on it, mostly on weekends or whatever. I think late night stuff. But I actually didn't stream because just too much work and all that stuff, and it's just I don't want to like do a stream where like I don't have a good idea on what I'm going to do, so I just didn't do it, right? And I think now I have a very good idea of what this is going at, like where this is going, and I think it's very comfortable to talk about it now, right? So basically, 3 months I worked on these few things, putting up a structure around scraping internet. And if you see, like, most of it is, of course, maybe not spec compliant, uh, and definitely we can do it much better. It just takes a lot of time to think about it and come up with it. So I don't know, maybe I can do it later. But basically, right now, what it does is three things. So it recognizes three kind of three or three internet data source, and we can basically split them into three parts. That's what I think are three parts. There might be more. So these three are basically a feed, any form of feed. So this can be anything from a blog of posts, right, or Twitter page, profile, right, or anything. LinkedIn page, anything, right? That basically is a feed, or basically you have list of pages, and then it can recognize anything that is a news article, right? So it can be anything from any news article, or actually, what, this is the third one. Second one is just plain internet search. So I'll explain why it's like this. So then we have internet search. So we have three kind of internet. Yeah. So internet search is basically, it will just search for a term and then load X results, right, or N results from all response, right? Basically, if you have one first page, second page, third page, fourth page, so it can just go around and get all the information that it can get, right? So that's basically is the internet source. Then everything else that we see that is not a feed, not recognizes internet search, it's false vector news, or anything that can be directly ingested, right? Which is a blog article, news article, any feed, anything that is just like a wall of text, right? Anything that's just a wall of text. So I'll explain how we are processing all of this stuff, right, later. So now this is what it recognizes as of now, and the way it's built is we have something called source. A source is basically anything that can give us information, right? So a source essentially can be anything where we can get some information. So it can be a link, right? A link to search, a link to a feed, a news topic, or any search query, right? So that's a source, right? And how it works is we have abstracted all of this to source runners. So what they do is they recognize the type of source, right? Source runners. So what they do is basically recognize recognize a source and then run on a source, right? So how it works is basically like it depends on how do we extract information from the source. For example, if it's a feed, the extraction method is different. For if it is a blog article or something or a news article, it's different. And if it is a search source, it's again different, right? So more or less like search part is easy because we can depend on any search engine to get index data and whatever, right? And then go through all the results, then extract information. That is easy. But the difficult part is feed. Even news articles are extremely easy because they follow a specific structure. I don't know if you've heard about it, but there's something called schema. I don't know if it is a thing. Yeah, exactly. Or is it a thing? Yeah, I think it is a thing. Yeah, correct. So basically, they have a structure around what it can be. So any news article or in news space can be uh, like you can reason about it in terms of a schema. So you get a lot of information. So how do we read all these pages is something, if you've heard about it, it's called Mozilla readability, right? So which is what it will do is it will go through a page and only like using accessibility tree it can extract information on elements that are actually readable, accessible. So it's basically our it's called reading view if you've heard about it. I think the vanilla Chrome has, right? What I am using doesn't have it, but the vanilla Chrome has it, right? And this is that. Then there is another thing called defuddle. So it's basically from Obsidian. So what they do is it's basically slightly liberal form of Mozilla readability, which allows a lot more uh, elements from content of a page, right? And just works on that, right? And it's slightly forgiving in terms of how it gives us data, right? So that is there. So what we're doing is for news and everything else, we use defuddle to extract data, and then we convert it to markdown, right? And for feed, the way it's written now is we have to implement every feed with a special one. I'll show you how it works right now. Again, it might not be spec compliant or legal per se, but it's just all experiment, right? I'm not going to earn anything from it, so I think it's fine. And then we have internet search. Again, it's very simple. We just do a search, get all the results from internet, and just go around it, right? Then go through each page, recognize what is the source, and then just build around it. Very simple, straightforward. So essentially, that is the data extraction part that we have figured out. Then after all of this, there is another part which is actually passing all this extracted data, structure it, and then pass it to a I don't know, maybe AI service, and then get valuable information out of it. So how does that work is like we get all text, right? Information from the internet, right? And then what we do, we just take all of it and just dump it into some LLM. So right now, the way it is structured is basically learning. So I have a lot of models now. I'm just experimenting, going through, seeing what we can do, and then I'll see what we can do there, right? And just give just give me a minute. Yeah, let's switch it up. Yeah. So basically what we'll do is like we take all the information, and I'm experimenting with a lot of models on local, because essentially it's going to be running on someone's system. So I feel it's better we set the expectations right from day one, right? Like it's going to run on Olam or whatever service, right? So uh, I'm just experimenting with all these models, and I think DeepSeek has been very articulate, right? Or I think Llama 3.2 is also super articulate. I haven't tried Gemma, but I think these two have been super articulate, and definitely DeepSeek has been slight slow. I think I showed you some context one, but yeah. So till this point, as you can see, it's very rudimentary. We don't have a RAG setup or whatever. So what we do, we take all text, then dump all of it in some model lemma, and then we ask it to ask it to summarize, right? So it's extremely rudimentary as of now. I haven't thought of a structure around it, so that I'm going to I'll explain how I thought through it, right? uh, so right now it's where we at. Then I have thought about a few other things after, and a lot of research also went into it. So basically my plan was to do something like this, right? So we get all this information, then we feed it, like we do two things, right? Just to put a structure, because we know what is a source and how the UX is going to perform, is we have, like, I don't know, maybe some chat box or whatever. Like we say, like it's basically a task based digest platform, right? Like you give it something to look at, right, every day at a certain time, right? And then it just goes through the internet and finds relevant stuff, and just summarizes or it whatever, right? uh, how I have thought about it is basically you have something called a source. I mean, I've already talked about it. So source is, it takes um, everything, like every like all data and everything. Okay. Broke. I don't know why is it not. Oh, okay. Yes. Yeah. So I think sources, we know like what it is, like basically any link or anything that can give us information. Then we have uh, task. So a task is basically a collection of sources that will run one after another, or maybe parallelly, I don't know, that I have to yet to build. Then every task will run at a certain period, certain time every day, right? And then when it runs, it will create two things. One, every source will have an associated source run. It's basically how you have, like, let's say if you're looking at an automated workflow platform, right? Every day at certain time, or like a cron job, right? It will run at certain time every day, and then it produces some output, right? And every source is going to be attached to a task, and every task will have a task run. So it's like source task and source run to task run, right? And every source run will create a digest, which is data that we got from the source, right? Then we do two things. We summarize it and keep it. Then we vectorize it and also keep it. So what do I mean by vectorize? We create embeddings for the text, whatever we got from the internet, right? Then we store it in some DB that we can search later. Then for every source run we do that. Then every task run we also do that. So how it works is, like, I'll write it out quickly. So it's like task. So every task has and every task has source, then again source, then again source, right? And every task has something called a task run. So that would be task run, then we have a source run, right? And again, same thing, right? More or less same thing. We have a source run, and I think let's just copy this entire thing. A source run, right? So every task has a task run, and every source has a source run which is associated. And what they produce is two things. Every source run, of course, because it goes through the internet and extracts information, so it will get first is content, so which is basically raw, not raw as in like processed, of course, but raw text information, information from the internet, right? And same goes for every other, right? Every other of them, right? And every source produces something called a like something content. So we just go through internet, find text, whatever, right? And we do two things. First, we store a summary of that summary, so this goes to digest, right? And every source run will have their own digest. So you see digest and digest, right? And plus, with along with the digest, we'll also create embeddings for all the text that we extracted from the internet, right? Embeddings for all. So we create a summary for all that text that we extracted, and embeddings for everything that we got from the internet, right? So what we are going to do with this is every task run is going to be a summary of all summaries, right? Am I doing it correct? Yeah, summaries of all summaries from source runs, right? Runs, plus there is going to be no embedding for a task run because it doesn't make any sense, right? Because task run content is already super condensed, it's from all sources, so it doesn't make sense, and it's of course is going to be very inefficient, right? We don't have that information, correct? I mean, it's already super condensed, so a embedding won't, like, it don't produce any output, like proper output, right? Plus no embeddings from output, sorry, from content, right? So this is where we are at right now. As of now, I'm speaking that this is where, like, this is still what I have built now, right? So how we have architected is basically we have a digest, which is information that we got from source run and task run. Then we create embeddings, so every digest can have an embedding of all the raw content of that digest, right? That produced that digest for every source run. 1 2 3, then we club it all together, create another summary for the task run. So let's say you are like, okay, I want to know about all I don't know, like maybe cricket teams doing amazing every month, like let's say, okay, let's say you are a super duper cricket fan and you want to know like how Ranji teams are doing, right? So how, what it can do is it can every source can be every cricket team of every state in India. Then summaries of that will be collected together for your task, which is getting a summary of all Ranji teams, right? And every source, because they belong to a team, they can have embeddings of the entire text information that we got from the internet, right? About how they are doing, right? So it's basically there right now. I can show you all code examples quickly. Let me just spin up my Vim. Okay, so I'll just directly go to migrations, priv migrations. So if you see, digest is very stupid. It's just like what digest we're looking at. Let me change color scheme. I think we need something super. Okay, this will be perfect. I don't know what is darker. Is it dark enough? I don't know, man. I think this is fine. Okay, cool. So how it works is like it's we have digest, then we have a task run. Again, as I said, like task run is collection of source runs, right? Then we have a source run. If a digest can belong to two things, is task run or a source run. And content embedding is basically raw embeddings of all, like the actual text that produced this digest. Then we have the summary. So this is not necessarily I think the formatting is broken. This is the I think I have to put a note. This is the summary and not the, right. So this is the summary, not the raw text that created this digest, right? And then we have simple like created operator. Meta is anything that about the digest. Like it can be where the source is from, but like what line numbers we are chunking right now or whatever, right? And just keep in mind, I made small mistakes here. For example, digest is like the problem is like if a source has massive amount of text content, right? So it can have n number of digests. So what do I mean by that is when we split raw content from that source run to let's say 20 pieces or 30 pieces or 50 pieces, right? Or 50 chunks, right? So there can be x number of digests. So that's a thing, right? So I think I made some mistakes, but what I am going after today is I'll just write it down. It's very simple. So what we'll do, we already have some what we'll do is we just look at I don't know, like some Wikipedia article, right? We'll just try to copy paste a lot of text information to our setup. I'll explain through how it's been written, right? Then we'll try to feed it to our vector DB, then retrieve it from the vector DB, feed it to LM and get some output. That's basically the goal. So how right now the status is I have already written all the tables that are going to um, like make the entire setup work, right? So we have sources, we have tasks comprise of sources, then we have task runs which comprise of source runs, then we have source runs which basically create digest and all that stuff, right? Right now you don't like, because a source run, a task run can have n just 1 minute n number of digests, so it doesn't necessarily do doesn't necessarily what do I mean by sorry for yeah, so there can be x number of digests, so we don't know, so that's why it's not a tape foreign key on this side. It's opposite, it's on digest to something else, right? So that's that. Then and it's partition, so I'll talk about SQLite Vec and how it works also, but basically that's how it's written. So I'll just quickly talk about what stuff here we are using here, because the entire source is SQLite Vec, or what lets us store all this vector and all this text information on our disk and then query through it, right? So SQLite Vec is oh no wait, this is not the one. Should be AGS, I think. ARG, I don't know, I forgot. I think it's this one. Yeah. So if you don't know, just quick intro to, I mean, whatever I have learned in last few days. So how it works in RAG is, or a request augmented retrieval system, is your LLMs have very less context window, right? So which is like we can think, or we can keep a lot of stuff in our memory as humans, right? But LLMs or machines cannot do that. They have very limited amount of memory, right? So to let them like capture a lot of information, give you very good responses about stuff that they're talking about, right? So we need we need to give them information, new information. For example, LLM can be trained on data that is 2 years old, right? But in 2 years there can be lot of changes that can happen in, like, in tech, right? So we cannot just expect it to know everything, right? So for that we use something called RAG or RAG, or request augmented retrieval. So which is, we request something, we get information, we change it to a form that LLM or machine can understand, then it will read through it and give us information based on whatever we gave it as context, right? And there are many databases that support vector, and vector is basically, again, I don't know much about mathematics. I failed maths, but basically vector is, like, you can think of a 2D space, and it's like linear algebra, right? I think it is linear algebra. So okay, so if you see, this is xy, right? And we have like something here and something here, and you see this is the x coordinate and this is the y coordinate, right? And this is again y coordinate and this is the x coordinate, right? So this is vector 1 and this is vector 2, and LLMs mostly read through these, and then they give, like, they understand through LLM. Also, I'm learning linear algebra, so that's a lot of stuff to grasp at once, right? That is there. But basically that's how it's going to work. Like, we take text, we convert it to vectors that LLMs can understand, we store it in some DB, then we use like, particularly for SQLite Vec, it's basically extension of SQLite database, and then it allows you to store vector and then run operations on it, right? For example, if I open up a reference, you can see yeah, these guys, right? So it's basically similarity search or nearest neighbor search and all that stuff. And then there is more techniques how you can improve that search. Read about it. But what we are going to do is, today we'll just try to ingest one massive Wikipedia article, convert it to vectors, store it in our DB, try to do a nearest neighbor search, right? And then see, like, what we get out of it, right? When we get all the results and then feed it to LLM and see how it behaves or how it responds. So just keep in mind, I haven't tried this. I am at this development stage, so that will take time. But basically that's what we are going to do today, right? And I'll just show you where I'm at. So news. Yeah, so you see, we have main here. So again, I'm using a language called Lean. So it runs an Erlang VM or OTP. If you know about Erlang OTP, or if you've heard about Elixir, so it runs on Erlang VM. It's like Node.js. It's just another runtime for a specific language, right? You can learn about it. But basically, what we are doing here is just acquiring a connection and then deleting all digests first. Sorry, going through all digests, then deleting all of them so that we have a clean slate, and we are chunking this text information. Then we are creating embeddings of it through some embedding library. So I use Nomic Embed. This is actually pretty cool and super fast, right? Then we put it inside DB, which is our SQLite Vec, that will let us query it, and then we just see, like, okay, get the data, and here we are just pushing it to the DB, right? And just 1 minute, yeah. So that's basically what we are doing now. And if you can see, there is a lot of stuff to be built here. For example, I haven't written all the models, it's just very rough now, and I am not running it on all the sources, as I told you, like, start of our stream, right? Like, a source is basically where we can get data from the internet, and they all of them implement this source provider type, which is anything can be a source, anything of these three. and then each of them implement their own scraping setup, like how do they extract information from the internet, right? Like all that stuff, you can read about it. And then we have three different kind of source runners. As I said, like a source what gives us data, and we have to run it, go like find those sources, and then get information, all that, right? So we have three kind of sources: feed, news, and search. Search will just go through the internet, get all the like all the links, and then we can go through it. And again, it's the same stuff, right? So we'll be looking at news source because it's the easiest one to implement a POC of, right? And what I'll do here is, instead of hello, actually I can show you a quick demo. To users, and if I run it, as you can see, I think it yeah, as you can see, so there are two okay responses, right? Which is, it went fine. And if you want to see how the embeddings look like, the basically look like this. Again, and you can see, so embeddings basically like bunch of numbers in the XY plane, right? And it looks very weird. I don't know if you know what I mean, right? And I think there are a few issues on how it's converting it to SQLite VEC compatible format. Definitely there is something getting lost. I don't know, like we have to figure it out. But as of now, we are able to take a string, chunk it, create embeddings for it, then feed it to our DB, right? So that's where we are at now. Just a minute. Just 1 minute. Yeah. So that's where we are at now. And what we are doing here is, we are just putting all those embeddings into the digest column. We have to fix a few things here. For example, right now it doesn't loop over all the embeddings. For example, if the string that we are chunking has multiple parts, right? For example, right now it just says hello bro. If I go to, let's say, wiki phantom, I don't know, maybe one piece. Let's see what we get. Okay. I just need a lot of text. I don't know where I can get. One piece on wiki, episode review. I don't know, like episode summary. Do we get that? Okay. What we can okay. Wiki one piece. Let's try this. What do we get here? Okay, beautiful. Okay, a lot of information. So what we'll do, just take all of it, right? I mean, I want to show off the scraping setup, but I feel it's better if you just focus on this, right? Just one. I think this has double quotes. Just to quickly remove all the double quotes. Just 1 minute. Replace all and double quotes. Oh, and I want to remove all the double quotes, and I want to convert it nothing. Awesome, an empty string. Oh, sorry. Oh my god. Why? Just 1 minute. Yeah, I want to convert it to single quotes. Right? So you can see, did it convert? Oh, okay, beautiful. Okay. So we'll just go here. As you can see, we have a lot of text information now. So I just want to see, like, before even we feed it to the DB, right? I'll just see like what evidence we get. Yeah, okay, perfect. So it's massive because again the text information is a lot, and just to see like how it works, this would uh, list. I have to, how do I do it? Uh, how do I log the, okay, maybe can I do this? I think that will log all the embeddings, sorry, chunks. Yeah. So as you can see here, you can see like this is being split to, yeah. See, so from here till I don't know where. I think here, yeah. So this is one chunk, and then from here, as you can see, there is slight overlap. So we are using something called recursive text splitter. So what it does is it keeps an overlap between two chunks or more, or like consecutive chunks in a massive blob of text, so that when we create embeddings and we search through it and we feed it back to LLM, it knows, like it knows the previous context, like basically, how do I put it, uh, like if you are going to ride a bike, it's imperative that you are a human, right? And if I'm going to explain that to an LLM and I have to tell that, okay, I think that's a bad example. How do I put it? Okay, this can be an example. So let's say you went to play cricket in the afternoon, and you like you got injured, okay, right? And why you got injured, that information maybe is in the previous sentence on when you are saying you are injured, or it can be after, right? But assuming it's before, when we are feeding it to an LLM, we have to tell that information on every chunk, because when we do vector search, it will search through every chunk and not a paragraph, right? So for example, if I am searching through this entire box, like it won't have the context of what is, like in the previous 500 characters, right? So the way we fix that is we have uh, something called overlaps, which is basically like from the last chunk, take n number of characters and then put it in the next chunk, right? So that's how it goes about it, right? uh, Pretty straightforward, pretty generic stuff, right? I think Langchain and all that is doing for a long time. In Elixir, I mean in Gleam, or where I'm interfacing, sorry, where I'm calling Elixir libraries, it's basically something called Elixir. Also, I don't know a lot about Langchain and all that stuff, but basically I know like how to chunk and all that stuff, right? So again, this is not the official spec. It implements the official spec, but it's not officially recognized. I don't think so. So it basically implements the original Langchain libraries which are in JavaScript and Python, right? So that's that. So what I just did, I just wrote a binding. In Gleam, you can like side load Elixir and uh, Elixir, Erlang or JavaScript stuff, right? So just that, very simple. Okay. Then uh, how do we go about it is uh, we vectorize it. So what we'll try to do now is, because it's already getting vectorized, what we'll try to do is we'll try to search through the DB and see if we can find anything valuable. Okay, just give me a minute, I'll be back. Oh, back in. Just actually slightly cold in Bangalore. It's just very. I don't know. I mean, it's normal for Bangalore to have this weather. Some it just randomly rains, man. I don't know. It's very very random. Yeah. Okay. So yeah, where I was at. We're going through the setup, right? So what I'll do, I'll just feed it. I'll vectorize all of it, feed it to the DB, and then we'll try to do a nearest neighbor search of a term. I think when you query, it has to be vectorized first. That is another thing. But I'll figure it out. Okay. Let's just go through some of the tests, I think, or maybe examples. I don't know. Let's see through the examples. Oh yeah, the query has to be vectorized as well. That's another thing. Wow, that's a tricky one. Uh, so this means like we can just like convert the string, or like we just need to vectorize it or something. That's another question I have. Not really sure, because the way it's written, it seems like we have to vectorize it to get a response. That is what I think. Right. I think I should take some rest. Okay, folks, it's difficult to focus, so what I'll do, I'll push all of it. This is actually a work of last few weeks. That's another thing, right? More. Uh, Set up. Maybe I'll do it tomorrow. I don't know. Like I'm feeling slight sleepy. I'll just go take some sleep. I don't know. Like I feel a little tired. Right. So you can go through this now. Like if whenever you want to, and it has the old plan that I had and the new one, like how it's going to work. I mean, this again has changed maybe, but you can look around the code, but the direction that we're going is mostly this, like how the migrations have been written, right? Like how we are going to structure it. So we have task sources, then task runs and source runs. We'll discuss about the UX in the next stream, but I think for today that's it. I'm slightly tired. Just want to go take some rest. Okay, so see you day after, or tomorrow. I think, not day after. Right? Thank you so much, and see you tomorrow. Bye bye. Tomorrow. Bye. Don't we have like a waving emoji? We have.